Good morning, this is your Stat Sensei, Mr. Spensei, and pre-quiz one sample proportions. This will be a confidence interval on the energy drink scenario. So suppose you work for a company that produces and sells energy drinks. The marketing team claims that the latest flavor, electric lemonade, is a hit with more than 50,000 consumers. All right, so looks like we have a population size of 50,000. It's believed that 60% of those who tried electric lemonade will try it again or will buy it again. So this seems like this is my claim. P is 60%. You are skeptical and are concerned that the actual percentage may be less and decide to test this claim using a random sample of customers who have tried electric lemonade. All right, so we have a random sample of customers. 97 customers who have tried electric lemonade are randomly selected. So we have a sample size of N is 97. And you find that 54 of the 97 say they'd buy it again. So X equals 54. Create a 93% confidence interval to determine the proportion of customers who would purchase electric lemonade again. So we have a confidence level of 93%. That's our CL. All right. So since it's a confidence interval, this is our basic confidence interval formula. P hat plus or minus Z star. And remember that sample proportion plus or minus Z star. Sample proportion, once again, if we're working with a confidence interval has P hat. The test has P. So if it's a hypothesis test, we're using P. If it's a confidence interval, we're using P hat. So consequently, right here, we're using P hat. We said that 54 people said that they'd buy it again out of 97. So 54 divided by 97. And this P hat, once again, P hat equals X bar divided by our P hat equals X over N. So the 54 divided by 97 gives me 0.5567. And they gave me the confidence level of 93%. Well, when I look at my formula, I was like, oh, I have P hat. So I got that part. I got my sample proportion. There it is again. There it is again. I have a sample size. So the only thing I'm missing at this point is Z star. So to calculate Z star, I need to go second vars, inverse norm, parenthesis 1 minus 0.93, close parenthesis, divide by 2, mean of 0, standard deviation of 1. And the reason it's 0 and 1 is because we're calculating a z-score. All z-scores are 0 and 1. We'll keep it to the left. And we end up getting 1.8119. All right? So there's 1.8119. And that's what we had. All right. One thing to keep in mind is when we're running a confidence interval, we're always going to be centered on P hat. So when we draw our picture, we're going to be centered on the 0.5567. We're not going to be centered on the 60%. So there it is, centered on 0.5667, and there's our 93%. And because it's the confidence interval, we know we're going to have a lower bound and our upper bound. All right, we've already calculated Z star at 1.8119, and we go to plug in. There's our sample proportion, plus or minus our Z star. Please remember, that's what that came from right here. And once again, please make sure that you're using P hat for confidence intervals. All right, we're centered on it. That's what we have here. Make sure that you always have that right. The procedure we're doing is a one proportion Z interval. Okay, so let's go ahead and run this test, even though it's a little bit out of line. Stat test, drop down to A, one proportion Z interval, and we have 54 and 97, and there's our confidence interval. So we don't know for sure how many people will buy it, but somewhere based on this, we have between 46% and 65%. 46.5 to 64.8% look like they would buy it again. So what's our parameter? Same as what we had before in our hypothesis test, that P equal the true population proportion of customers who would purchase electric lemonade again. Key word there is to make sure we're talking about proportion. We're no longer working with means. Continuing on, we need to do our conditions. The first condition is random sample. The second condition deals with the population size. Well, they tell us that they have a random sample of 97, so that's good. And they told us our population size was 50,000. So we have a random sample of 97, and I'm going to scratch out the word select. I'm going to say sample. Random sample of 97, and that was given. And I'll check that off. By the way, random select is fine. I just prefer sample, so I'm going to write it. So n is 97, and 97 times 10 equals 970. All right. And that 970 is less than our population of 50,000. So we can say n is less than 10% of the population. All right. Next, we need to check. So that says that, hey, is our sample too big? And the answer is no, because it's less than 10% of the population. So that's good. The next thing is we need to check is it big enough? Super important. Look here. When we're running a hypothesis test, it's P, but when we're running a confidence interval, we're using P hat. So 97 times 0.5567 is 53.9. That's greater than or equal to 10. That's good. We can check that off. Then we have 97 parenthesis 1 minus 0.5567 close parenthesis, and we get 43. That's greater than 10. So that's good. So now we can say the sample is large enough. Now, if there's AP statistics, you want to say the sample is large enough to use a normal approximation. But for right now, that's all we're going to look at. We've already calculated our interval, so we're going to go ahead and write our conclusions. So what are we? Well, we're 93% confident that the true population proportion of customers who would purchase electric lemonade lies within the interval 0.4653 to 0.6480. So the one thing I just want to point out to you again, true population proportion of customers who would purchase the electric lemonade again, that right there is the restatement of my parameter. Finally, the meaning. In repeated sampling, we expect this method to capture the true population proportion of customers who would purchase electric lemonade again 93% of the time. And as we had before, that right there, in both cases, this is my parameter. And this is my parameter. So please always take time to write a good parameter because we use it over and over again in our conclusions. It gives the right context and gets you full credit. All right, appreciate you watching. Look forward to seeing you on the next one. Thank you.